All right, folks, welcome back to Social Networks and Health Day 2. The next hour is you get to put up with me again for a little bit of time. So what I wanted to do next is go over two different bits that I think get a little out of order in terms of where things might have gone. I want to spend the first part talking about centrality and block modeling under the rubric of positional analysis in networks, because I think gets a little bit less attention. And then the second part will be to talk on peer influence and diffusion models. These are both pretty core, I think, to the ways that social networks and health researchers, in particular, that as people are interested in using network analysis for applied work, these topics are pretty simple for that kind of work. So I think in that sense, it's kind of useful. The presentations that we have on the website go into this in great detail. If memory serves, it's something like 200 slides or something ridiculous like that, which is about 20 minutes for me. And then so I've boiled that down now to something a little less than that, and so hopefully it'll still get the point across. So I'm just going to jump in, and if folks have comments or questions, just go ahead and stop me, of course. Get this thing going. All right, can we see that? We're really close to awesome. Okay, so research on social networks and health. When I just recall the rubric, we kind of set up the whole class and book. The way I think about networks goes is between this notion of connectionist models and positional models. And the connectionist model, recall, is diffusion and peer influence, which we'll get to next. Positional models are really about how your spot in the network, whether you're at the simple version, whether you're at the periphery versus the core, for example, how that changes how you experience whatever social setting you're in, and by virtue of that is going to change your behavior or your health risks or what have you. So what do we mean by that? It turns out there are a number of things that fall under the positional rubric. The two that I want to focus on now are centrality and block modeling. And even then, I'm going to do the centrality part pretty quickly, but we'll get to that in a second. For those of you that are interested in it, I just want to put this up here to just remind us that the notion of role analysis and positional analysis in sociological research is really old. It's been around since at least the 30s or 40s. And it's an offshoot of the work in structural anthropology. And the work that was done there, the traditional work in it, was from kinship models and kinship structure systems. There's a great talk that Ashton's going to give tomorrow on using these kinship models to be able to think about the ways that kinships expand, to think about things like bereavement or what have you. So it's not a dead field even on the old part, which is the kinship structure model. But the insight that White, Borman, and Breger had was that what we can do with known relations like child of or husband of, those kinds of known relations, you could also do with informal relations. So, a sycophant of a group member is what? And so those kind of pieces allow these things called compound relations. And that's a really technical way of saying there tends to be a logic that underlies role systems. And part of what the task involved of doing the kind of modeling is to try to discern what that is. There is work that does it formally in semi-group analysis, and Philippa Pattison has an entire book on this, which is just wonderful. But most of us do it much more informally, just to try to describe intuitively what these structures look like. And I'll give you a little sense of that. That's what that says. So this is my favorite way to describe, for those who've never seen a positional analysis, like what it means. So imagine I give you a network of 5 nodes and point out to you that 2 of them love each other romantically, that those 2 feed 3 people who fight with each other all the time. And you probably recognize this as the classic sitcom family structure, at least in the Western sitcom family structure. And parents sort of live by this love-hate fight with their kids, and kids are always struggling with annoying their parents and what have you, and annoying each other. So we can see that, and we know that intuitively by the structure of the relation. The labels really just capture this. And if you go back and read this, some of the early work that White did on this, one of my favorite pieces is his piece called Cat Nets, which is a summary of a series of notes he gave when he was teaching an intro on networks class. And he makes the clear point that what makes a label, what makes a category like parent or child, is that it structures relations. There's a duality between the category and the relations that is in fact definitive of each other. To come up with a category label that has no bearing on social relations is irrelevant. I mean, it's literally not a social category. And the flip side, of course, is that the only social categories that matter are those that structure relations. And so if you think about it, things that we are used to thinking of as core categorical features, race, gender, class, these things. If it weren't for the fact that, our social relations and the way we treated each other differed by these things, it would be unlikely that we would actually claim them as being important. And so that's the point that White's trying to make. And I think that it's easy for sort of the individualistic bias that we have from Western social science to think that it's the category that's driving the relation. But what White's really proposing is that this is a dual, that the category is defined by the pattern of relations, that it doesn't mean anything to be a parent if you're not feeding kids. And so this idea that there's a relationship there that is defined by the pattern of relations, or an entity there that's defined by the pattern of relations, is really what's central to the understanding. And I think it's really easy for us, because they're so much easier to measure status characteristics, that we say that this person is white, this person is black, or what have you, as opposed to the harder work, which is really driving that this person can get a loan, this person can get a job, and this person gets arrested. These kinds of things define the category that we then put a label on top of. And so being able to see it that way is really the heart of what this kind of analysis is about. Now, informally, I think there's a lot of different ways that we can methodologically go about doing this. So that's the formal theoretical background, but there's sort of a light version of a positional analysis and a deep version. And the light version falls under this whole heading of centrality. So there's all kinds of ways in which we measure a node's position in the network relative to other nodes in the position that have something to do with a continuum between core and periphery, where that continuum is defined in various different ways. But there's lots of other ways you could think about categories of nodes defined by patterns of metrics, right? So it could be like an isolate as a loner, or a leader as a person who has lots of in-group ties. A bridge is somebody who has ties that cross groups. And so part of this is what I want to do is just sensitize you to this idea that any of the measures that we calculate on a network, any of the metrics we have for a node of a network, could go into thinking about it in a positional sense, even if that measure, like degree, is typically thought of as a connection sense. It often signals more than that. Okay. So the collective property sense, I think, of networks is of the role one is the one that I think people tend to think of when they think about role analysis or positional analysis, and this falls under the rubric of block modeling. And so we have a whole class of people that share a situation, or that share a set of metrics. I think in practice, this notion of an individualist notion that we might capture with centrality versus a collective notion we capture with role models are really two ends of the same coin. You can, as many times, you don't have a perfect membership in a role. Neither do you have people who are exactly the same on the centrality score. So these things are all continuums, depending on how much you want to slice it. All right. So there are, I don't know if I put my little, I didn't put it here. I have it hidden if we want to go back to it, but there's a nice little slide of the periodic table of centrality scores, where some clever person went through and found all of the centrality measures and sort of put them into this great little diagram. And what I like about that is just to say that there are a lot of centrality measures. Most of them turn on a couple of different features. It either has to do with a radial set, that is how likely information starting from this node could find its way out to the network, or infection could find its way out to the network. And the classic version of that is closeness centrality. And the other version of this is something like your ability to block the flow of things through the network, or to span different parts of the network. And the classic version of that is between centrality. If the closeness between this, Bonifich, if these words mean nothing to you, just go check out the slides. I'm happy to answer questions about them. But fundamentally, they're different ways of defining what it means to be important in the network. And the best thing about centrality scores is that they capture one thing well. So, between the centrality means exactly the number of shortest paths in the networks that you interrupt. And so there's a lot more going on in most social networks than just the number of shortest paths that get interrupted. And so it certainly doesn't capture all of the notion of what it means to be in a position, but between the centrality by itself captures one thing really well. And what that means is that if you have a collection of centrality scores, each of which measure a dimension of your position in the network really well, collectively, you have a nice summary of the overall position of a node in the network. And I've used this slide, for years now. It's just a rubric to help you think about occupying multiple sort of places in the network simultaneously. And I think for today's discussion, what it does is it highlights this idea that if I give you a node and a vector of centrality scores, it really defines a unique pattern that they occupy in the network. And so, for example, someone who has high degree but low betweenness is somebody who has lots of redundant connections. So they only have a few connections and they go around. Whereas the flip side of that, someone who has really high betweenness but very few ties, that's someone who's like the classic Ron Burt structural hole bridge that it can sort of find a way across people. And so I think what's nice about this is if you could imagine taking a whole series of centrality scores, clustering them, and finding nodes that have similar patterns, you could probably tell a story where you define that pattern in a similar way. And I would encourage you to maybe be creative that way if that's something you're interested in doing. So the more standard way to do these kinds of models is to think about block modeling and roles as a collective property, to look for a set of nodes that share the same pattern. And so this is an exact analog to the community detection routines that we talked about a minute ago. And it brings with them all the same problems that community detection brings with it. It's just instead of looking for nodes that share lots of direct ties, we're looking for nodes that share lots of similar types of ties to similar types of others. So we've replaced the adjacency matrix with the similarity matrix. And then from that, we try to identify nodes that are, tightly very similar to each other. So that's the goal. So how do we do this? In practice, the traditional way to do this is, and I think the way that works best in many ways, is to use a multi-relational network. So you take something like the little example I gave before, and you take your romance network, your feeding network, and your bickering network, and you look at them simultaneously. The way to look at them simultaneously originally was called stacking. And so you would take those four adjacency matrices, and you'd turn it, there's three adjacency matrices, and you turn it into a multiple column or multiple rows where each node is repeated as many times as there are relations. In this case, because feeding is a directed relationship and the other two are symmetric relationships, we include both the direct and the transposed version. And this gives you not only who feeds who, or who does a lot of feeding, but exactly who gets fed. And so you can, in a small example like this, that doesn't make any difference. But if you have long chains in your network, then that distinction because you can be someone who only feeds, someone who only receives, or somebody who both feeds and receives. And so that's the kind of thing that you want to be able to take care of. Once you have that, you then take all the information you have at your disposal and you summarize that down to some kind of similarity score. Now, because this is a made-up example, what you end up with is two types of nodes. You have the parents that are exactly similar and the kids that are exactly similar. And so in this case, it's a pretty trivial clustering problem. But the idea is that you could do that on a network. Of course, social network researchers have done a lot of work sort of going off that intuition and doing more exact things with it. And the key part there is they've defined lots of different kinds of what are called structural equivalents. That's what this means. If we're similar across all these types of relations, we're structurally equivalent. And the exact definition of what structural equivalence means, I'm going to gloss over because in practice, just to be honest with you, it doesn't matter that much. It matters mathematically, it doesn't matter pragmatically, in the sense that when we go to operationalize these measures, it tends not to make a huge amount of difference because there's so much noise in our data that we end up, they end up essentially looking like each other. One of my favorite kinds of equivalence is built on triads, which I refer to as the periodic table of social elements. The idea here is that whatever social activity people have that embeds them in the network, it's really, a pair of people compared to everybody else. And that nicely summarizes the relational activity that a person is engaged in. And so any rule that you can have on a network, like a friend of a friend is a friend, or that the people agree on who's the boss, like these kinds of things can get incorporated into patterns on the network. And that's what this little thing does. It says that each of those 16 triads can be thought of as your involvement within the triad. So in the O3OC, everybody's the same. Each person sends one tie and receives one tie, and it doesn't matter where you are. But if you're in the 2010 triad, you can either be the person at the middle of the bridge, you can be the person at the top, or you can be this person at the end. And so each of these defines slightly different patterns. And if you have a lot of these kinds of positions, where am I at here, such as this, right? If you're always the person in the middle of paths, you're probably much more likely to be a bridge than if you're usually the person who is, sort of starting a tie like this over here. And so you can characterize a person's position by their pattern across relations to every other pair of people in the network. And in the interest of time, I'm not going to go through this in great detail. This is an example of using this model on the Prosper data. And what's nice about it is that we really did it sort of fell out nicely to describe what's there. I thought I had a better summary of that. But the basic idea here is that what we found in this case were 8 clusters, and those 8 clusters appeared to be a really nice combination of differences in popularity, which we call hierarchy, differences in overall relational activity, which is the volume, and the differences in reciprocity, the extent to which you have these tight cohesive clusters. And so at one pole, you have what I'm calling this leading crowd. These are folks that have a very reciprocal, high volume relations, and everyone else likes them, and that's what their pattern looks like. Whereas down here in the opposite end, you have people who are really just completely outside of the structure, and lots of different versions in between. And it really popped out nicely from the way these data did. And if you go through and look at the full presentation, you'll see we give you the set of steps required to get to this kind of analysis across lots of networks simultaneously. What's also nice about this kind of approach is that you can apply it to, it can really be a good way to analyze giant networks. And so many of us now are coming across data with millions of nodes or billions of nodes. One of the things that's interesting about our measures of equivalence, particularly automorphic or regular equivalence, is that at the end of the day, what the measure says is that 2 nodes who are equivalent will have the same node level metric on any node level metric. And that really sort of frees you, because a lot of node level metrics are pretty fast and easy to calculate. And so if you can do that, if you can go and collect a bunch of node level metrics, calculate them, those then just become elements in a vector, which are easy to cluster. So then you have any kind of categorical cluster kind of analysis can be used to identify nodes into structures. John Morgan and I did this on some data that, if I remember right, this was our GitHub data for a DARPA project a few years ago, and this was a networks of, was on the order of 50 million nodes. And so it's truly insanely large numbers of nodes in the network, but you can still cluster it in a way that's relatively easy to find. And in this particular case, you ended up with 8 roles, and those 8 roles fell into variants of core versus periphery, or 9 roles, excuse me. And it was nice because that allowed us to sort of really come up with a way of understanding what was happening in this particular software sharing environment. That you had a lot of people who were essentially users that just drew things from the network, and others who were producers. And then the ones that were kind of interesting were people like these bridges, or these other kinds of either large scale bridges or local bridges that were in charge of doing things. Looks like this is actually the Twitter version of it. We did this on 2 different kinds of networks. But it's a nice way of getting to a kind of node that you can then say something interesting about, as opposed to trying to, actually make sense of the heterogeneity that comes with, millions of nodes. All right. So I think that was a very fast way of going over this work. I think that the key point that I want to drive home is that there's a lot more to networks than just saying, am I connected to somebody who's going to give me a disease or who's going to make me make bad choices? And instead, we can think about these positions as characterizing ways of living. And these positions, once thought of that way, can become a much richer way of describing the network and understanding different social systems than you might have otherwise. So I'm going to stop there and take questions, and so here we go. So thank you for listening. Comments, thoughts, suggestions? Peter, please.
Well, that was just me clapping for you.
Oh. One of the things, the reason I thought Peter, what I thought Peter was going to ask was like, what is this? Like, isn't this just community detection?
Well,
and,
I was gonna, I mean, you know, I was gonna wait another 30 seconds and see if anybody, you know, like the professor standing at the front of the room, awkwardly waiting for someone to say something.
Fair
But
enough.
if nobody does, I mean, I think that, you know, one of the things you and I are dealing with right now is how to talk about the ways in which this is both similar in some ways to community detection, but also doing something, you know, substantively different.
Yeah, and I think what's really been encouraging for me anyway is I think that there are we've sort of converged on much of the same set of solutions from starting from wildly different sort of places. So the original work on block modeling, the two algorithms that came out of that work was Concore and Rege, R-E-G-E. Concore is essentially singular value decomposition applied repetitively to a similarity matrix.
Right.
Which is kind of, you know, which was not that different than spin glass as a community detection, but without really a good stopping mechanism. There wasn't anything equivalent to a modularity maximization to say stop now other than the user's intuition. And I think what's nice about it is that people have come to recognize that and realize that essentially there's lots of things that we used to do with cluster analysis generally, or Concore in particular, that were arbitrary and not necessary. So you don't have to, for example, split the tree the same number of times down every branch. You can have one branch that splits early and then go deep in another branch. And that kind of intuition is nice, especially if you say, well, what's a good rubric? Well, one rubric might be modularity. So I convert any correlation greater than some threshold to a tie, call the others not, and treat it as if my similarity metrics were a connectivity matrix, and then run my modularity score on it. Rege, on the other hand, really thought to implement this similar nodes to similar alters. So it was a double recursive algorithm that compared each node's pattern of ties to every other node's pattern of ties 2 steps down. And it was slow as bejesus, when it turns out that in fact you can get 90% of the way there just by clustering on summary scores of the nodes. So I think that those are things that we've learned by thinking about it as essentially a type of yet another unsupervised clustering routine, just applied to a slightly different set of problems.
Right, but just to riff on that briefly, and please, someone else raise a hand if you want to stop this conversation, because God knows Jim and I could talk about this for hours. I mean, I think what you're hitting there is really important, right? That it's now an unsupervised clustering on these summary scores, because then what you're doing is you're clustering people based on, again, just to keep using the word, the role that they are playing in the network, that role being captured in whatever node level features you are stringing together to cluster. Whereas like you said, I mean, Concore is basically like any other divisive method, you know, and then you kind of had to find a way to stop. I mean, the thing that everybody always forgets is that actually Mark Newman and Michel Gervin initially introduced the concept of modularity as a measure, as a stopping criteria for their edge betweenness based divisive algorithm. So they were taking the whole network, identifying sort of the most important edge in a betweenness sense, snip it, recalculate, snip the next most important one, et cetera. And so you, as you just said, right, you just end up with a tree with nothing besides your own intuition about where to stop. And so they introduced modularity as the measure to pick where to stop, and then said, wait a minute, if we're picking the level of the tree to maximize this quantity, why don't we just maximize that quantity to start with? And the rest, you know, and then that's, you know, that's what we're doing 20 years later in that area.
Yeah. It really is. I think that once you recognize that these are mere problems, you also recognize that there are in many ways probably analogous, like open problems. So one of the things about community detection that people always wring their hands about is that we expect communities to overlap. In real life, you can study both race and gender if you're a social scientist. You don't have to be in the race cluster or the gender cluster. But it turns out that that's also true with roles. You can be an uncle that's more like a father than you might otherwise be, because your relationship with your nieces and nephews has more responsibilities than it should have in some ideal, typical sense.
Right.
So the extent to which these roles overlap with each other is something that I think, to my knowledge, almost no one has spent any time thinking about, but we could just as well.
I don't want to interrupt.
No, please do. Oh my God, please
It's
do.
really, I have to say, it's very enjoyable to listen to two people who know so much more than me discuss intelligently about these things. It's great. But I do have a not terribly interesting question, which is, you were talking in the slides you provided, slide 61, where you're talking about the 8 different communities. So the people who have like reciprocal relationships and everybody likes them. And then there are the uninvolved outsiders. These names are great. I know it's said it's not very interesting. I want to dive into this more. Where is this from? What is it from?
Oh, this is from an unpublished set of work on profit that
okay.
I get to finish. So yes, that's why. So this is where it lives.
Gotcha.
It should be coming out in a book that we're working on right now to summarize some of the Prosper results.
Okay.
So, but yeah, otherwise I'll send you the full set of slides from this result, and you can provide me some ideas about it. That'd be great. So.
Great. Looks fascinating. Thank you.
Jim, dare I ask, how many books or book chapters do you have up in the air right now at the same time?
You really don't want to know.
Okay, sorry. That's for the alcohol consumption part of the virtual meeting that we would have had if it were.
Or summer, right? Isn't this the time you tackle all of those?
Yeah, exactly. Now, the things I owe my colleagues is deeper than the things that I owe myself. So that's the problem, but that's a different story. I do think, just to go back to the other side, one of the nice things about that example that popped up, and it's probably not worth sharing my screen again, but when we originally started thinking about what roles in schools look like, one of the nice things about doing a role analysis in schools is that, you know, Americans have a pretty good intuition about what it was like to live in schools, because we all went to one. Most of us went to a pretty standard one. I won't tell that story, but we all saw the same movies about bad high schools, right? And so we kind of have some generalized, you know, Ridgemont High version of what a school should look like. And there's this rich literature of ethnographies coming up since at least the 50s, all the way through Cairns and Cairns and such in the 90s and early 2000s to build on. And so if you think about something like the Hangers-On or the Leading Crowd or something like this, those names are not arbitrary. The Leading Crowd was something that Hollingshead and Coleman invented, like I said, in 1950. And so it's a role that we really expected to see, and it was pretty clear that it popped out of there. Jimmy, you had a question.
It's probably for another time.
Someone with more restraint than myself or Peter. All right, great. Anyway, this was my obligatory thing that says, we've spent an entire, the social networks in health. I love it to death. Obviously, we spent this time doing it. My probably biggest complaint with the field and as a whole, and with networks these days as a whole, is the over reliance on connectionist approaches. There are many times when which the only question of interest is peer influence, and the only question within peer influence is it causal? And so I think both of those are fine questions, but they're only a tiny slice of the set of questions for which we could do really interesting things. And this is one of the branches of interesting things I'd like to see more work done on. So, all right. So I'm going to now, in the I'm going to stop my recording.